All right, so we're doing week 17 of the Beginner Boost, and we are going to jump into programming. Now, obviously, we already did a bunch of programming 2 weeks ago when we did the tripwire thing. We used the find command to go back and find all of our files that have changed since the last 24 hours to catch hackers. And so you can go back and watch that. But that was the kind of the, get our feet wet into programming, and we're going to return back to that. But today, we're going to start talking about programming using a little bit more formal terminology that you might hear in a computer programming class. However, we are going to do something that's extremely unconventional for programming. We're going to learn how to code in shell as a first language. And somebody out there just groaned and went away and went to watch another station. And I want you to hear me out. I want you to hear me out. This is actually something over the last 10 years. So let me give you a little bit of history here. So when I started SKILSTAK, I was like, what's the best first programming language for a beginner? And I did a lot of research, and I taught Python for 5 years. And it was fantastic. Python's a great first language. It's very generic and all of that. You can learn a lot with that. And then I like, well, yeah, but you can't do anonymous functions. I mean, multi-line anonymous functions. So then I started teaching JavaScript as the best first language. And all things considered, if you have no knowledge of the command line in Linux, I still believe JavaScript is the best first language for someone to learn. Especially if you're teaching it in an environment, an education environment, the chances of people being able to go, you can go in JavaScript. We're going to learn a little bit later, but you can open up a web browser, any web browser, and you can open up the developer tools, and you can immediately start coding in JavaScript. So you don't need to go do, a class or anything. You can kind of follow along or experiment or find somebody's project, but you can code in JavaScript immediately, and you have JavaScript. Everybody who's listening to me right now or watching me on a web or anything, you have a JavaScript interpreter built into your computer right now. So it's a really great first way to get it. Also, if you're particularly appealing to the 8 to 18-year-old set, JavaScript gives you the ability to integrate graphics and things that Python does not allow you to do. Yes, I know there's tkinter, we did it, but it's not as rewarding. And when doing JavaScript, the kids usually end up with a project that they can show to other people on the internet. So I still maintain, and there are tons of great streamers about this, streamers and live streamers and educators that will teach you web development using JavaScript. So if you are that person, if you are just interested in becoming a software engineer or becoming a web dev, then I encourage you right at this moment to research that for yourself and go do that. Just today, I just announced, by the way, that I'm going to be adding beginning learning to code streams back. You'll start to see that on YouTube, on Twitch. I talked about that in another video earlier, but the reason that I am not doing JavaScript, which I absolutely love, or Python, which I also absolutely love, even though I kind of threw my stuff in the street once upon a time. I've had a love-hate relationship with Python for a long time, and we'll talk about it when we do Python someday. Or Go, which of course everybody knows is my daily, bread and butter language, because I get paid to code in Go all the time. Why am I not doing one of those languages first, right? Well, the reason is because the Beginner Boost is highly, highly focused on terminal Linux skills, okay? And the terminal Linux skills are, fundamentally based around the shell. And we've talked about that a lot. I don't want to have to talk about that again. We've already covered how the shell, and when we did the tripwire thing, we talked about how you are already programming. And this was the real eye-opening moment that I had when it comes to education, which happened a couple of years back. But when I started streaming, I was like, you know what? Everybody is already programming. And I was trying to weigh, I promise I'm almost done. I was trying to weigh the first programming language people learn with how to have people customize their shell and write their own bash RC files. You see where this goes, right? So not knowing how to write your own bash RC file and maintain it because you're learning Python as your first language, those were kind of at odds. And I was like, I had this moment of aha. It's like, why don't we actually try to teach shell as the first language that they learn? I'm like, oh my God, who would ever do that? And so the reason we're doing shell first in this context, that's why I talked about all that other stuff. In this context, the reason we're doing shell first is because you've been using this shell this whole entire time. And that project we did 2 weeks ago showed that, right? You can any command that you can do on the command line, you can put into a file, boom, you're coding. Okay? So you're already a coder. We talked about Code Birthday when we did that. But that is the reason that we were doing shell. Now that's a big long disclaimer, but hopefully you stayed with me during that because it doesn't make any sense. If you go to the average educator out there and say, what do you do? Oh, I teach programming. Oh, what programming language do you teach to beginners? Shell. And I'm like, what? Now there is actually one project. There's we have a friend from Morocco who is actually what is the project? There's a French educator who has a very accelerated project, and they teach C and shell coding as the first programming. And I think that's really amazing, actually. But that's if you don't have any other agenda, right? There's no other agenda. You don't have to, woo people into coding, with fancy graphics and stuff. Otherwise, they'll lose interest. People who truly want to understand how their computer works. And I forget the name of the program. Does anybody remember it? There's a program. There's an education program. There's a school. It starts with an H, I think. I can't remember it now. But anyway, it's one of the better ones. And it actually does. It does C and shell as the first languages. And there's a lot of reasons that I think that makes sense. But I hope you understand that at this point, you understand my decision for using shell as the first language for this context, right? And I do think everyone should learn C eventually if they want to learn how their computer works. Particularly hackers. Hackers really need to learn C because they have to understand how the code that they are hacking, sucks. So, anyway, let's get going. So why? So I think I talked about why learn shell as a first programming language. Okay, and so then the first thing is the next thing we're going to do is how can I create a program / script? All right, so let's do that. So the way to make a program, we already did Git and GitHub last week. Okay, we're gonna do some Git. I think C is a great show. It's not CS50, no. CS50 does it the same. It teaches C first. Yeah, there's a couple. It's not CS50. CS50 is good though. It's free and everything. So what we're gonna do now is we're gonna go to our Git repo, right? And so we covered this already. I'm not going to cover it again. We're repos. And we have GitHub. We talked about why you should make this organization. I'm not going to repeat that. Go back and watch that last week. And I've got a lot of projects in here. You probably have one or two. We committed our first project and we created our first project last week. We finished that, if I remember right. It's not HackRector. No, it's not. It's in France. It's a French guy who made it. A couple of people have asked me about it. It's a European thing. And anyway, sorry, and everybody's trying to help me find that. I'll find it and report on it. So let's go into so this is, I don't know what you called yours. What did we call ours last week? Does everybody remember? What did we call it? Boost. It was boost test. Okay. So boost test. So here I am I have my boost test. And here, this is just a test repo. We did the whole Git commit thing. We are not learning Git. I just need to say that again. We're only learning the minimum amount of Git in order to do backups. We're not using Git branching and all that stuff. That will come in one, if not all, of the coding stuff that we're going to do eventually. So here we go. We have our boost test, right? So what is the first thing that we're going to make? Well, I like to keep things project-based, but when it comes to the first language, I've had actually extremely good positive feedback, including unsolicited feedback from people that I mentored later in life who said, I absolutely loved that you did these tiny little projects to emphasize different ideas about coding. And so we are going to do that. And we're going to actually keep it a little bit fun at the same time. And I've noticed that one of the things that people like to do when they're doing coding is integrate color into their stuff. So the very first program we're going to write is going to be Hello World. Everybody writes Hello World. And I'm going to take you through the steps to do Hello World. But after that, we'll probably get to several others today. And then we're going to do Hi. And we'll create a program called Greet, and we'll learn about arguments. And then we're going to create a program that does a little bit of binary counting. And we're going to kind of progress that way. And as we do, we're going to talk about the different parts of scripting based on the need for it, as if you're like, oh man, I wish I could do this. Okay. So we've already done the steps for creating that's not, I don't think that's it. No. Anyway, so we've got, so if you don't, you're going to go find your GitHub repo, pause the video, go back and watch the other video about how to create a GitHub repo before you do anything else, because it's really important that you have that GitHub repo created right now. And I'm going to use a command called touch to make a program. We're going to call it hello. And why did I use touch? I've talked about this before. The reason you want to use touch to make a new file is because if you happen to be in a place that you don't have access to, like as an admin, this happens all the time, and you try to do this, hey, echo hello, right? And you save your program, and you're like, I can't save my program. Oh no, right? Because VI will happily open the program and let you write a whole bunch of stuff that then is going to get thrown away. By the way, this is how I've already done this before. I'm going to do it again. The way to recover from this problem is to do :w temp foo or whatever, and you see that how it overwrites it. Now you can close out. You can do shift q : exclamation point, which does not save anything, right? So there's still nothing in my Etsy. I didn't hurt anything, but now I can go look at temp foo, and if I actually really wanted this to be here, I could sudo copy temp foo to here. I'm not going to do it, but that's what you could do. Okay. That is why I use touch, because if I try to do the same thing, if I try to make the same program using touch view is like, oh, you can't make it because you're in the wrong directory. I'm like, oh, I'm so dumb. I am in the wrong place. All right. That is why I use touch. Okay. And it just makes it faster. Right. And then I have schmox as an alias. You should already know how to make aliases now. Chmod plus X. Chmod gives the chmod plus X. We're going to cover the chmod command gradually over time. We're not going to do the octal stuff until we do our script that counts an octal. So right now we're just adding executable permissions to our help program. We've covered this before. So there we got it's red. We can do ls-l. We see that it's now red. We have a program that has 0 length that can now be run. You can actually run this thing, but does this run it? Nope. Why? Pause the video. We cover this. It doesn't run it because it's not in the path, right? It's not in one of those directories that's in our path. And path, by the way, is a path. Here's what's in my path program. I'm going to I don't like using things that you don't. Here's my path program. This is using a bash-ism called a parameter expansion, which actually replaces all the line returns with just a line return. So otherwise you'd be dealing with this. You'd have to look through that, right? So you're going to learn how to do that. That's one of the reasons we're learning shell, so you can do those cool little things and add those to your bash RC and, prosper. Okay. So we have this program now. So how do I run it? You should know this, /hello. We covered it, right? What does / do? It says run the thing in the current directory. What does the dot mean? Current directory. What does dot mean? The directory above, right? So let's actually do that. Make a subdir, cd subdir. What if I wanted to run hello from the subdir, / hello? It runs, but there's nothing in it, right? / hello, is that going to work? No, because it's in the directory above. How do I go up? cd .. Go back up. All right. So now we can remove that directory subdir. I just wanted to show you that. It's kind of a review of the stuff we already covered. So here we have hello, right? Now this is where you can do git status. Okay. You remember that whole thing about using git as your ongoing backup? Well, this is a good time to do that, right? And last week we talked about committing often, right? Commit early and often, as they say. In fact, you can go look that up. Commit early and often. We're going to ask ChatGPT what ChatGPT thinks of committing early and often. The phrase commit early and often is a common principle in software development. It means the developer should frequently save their work by committing changes to the code repository. This ensures the history of change is well documented, allows for easier collaboration and tracking progress. By committing early and often, developers reduce the risk of losing work and can easily revert or merge changes if needed. It also helps in redoing and validating code changes, blah, blah, blah. There's lots of good reasons. Thank you, ChatGPT, for that wonderful instruction. I actually agree with that, which, you usually want to do. So that's why we're going to commit. So why would I commit an empty file? Well, maybe I just want to know that the file is there. So let's actually do that. So if we could get status, we see that the file is not being tracked at all, right? So if I try to commit that, it'd be like, you got nothing to commit. No. So it'll get add. We had a new file. We get add a file, get status. That's going to show us the file. Okay. If we wanted to boot it out again, we could do that whole restore stage thing, but we don't need to do that, right? Now, you don't actually need to push your file up to, GitHub right now. You really don't need to do that, but you can. You can. And the advantage of that is that if you do that if your computer melts down, you actually have a backup copy up on GitHub. Right now, we don't. We have a copy, though, so watch. I accidentally remove it. Oh, no, whatever will I do? Git restore. Hello. This should work, actually. Oh, whoops. I was like, why is this not completing? Store, tab, hello. Hey, look, there's the file. Okay, because what did it do? It staged it. It backed it up locally, right? But if I want to back it up to GitHub, backup being kind of a generous term, git push, right? So now what? Git status says everything's up to date. Oh, wait, I forgot to commit it. I added it, but I forgot to commit it. So I pushed it and it said, no, I pushed it. It's not the push. So let's do that. Git commit. All right. And we can put it here, but I'm going to exit out of that because I'm going to do -m because I'm lazy. I'm going to say add hello script. Okay. And now I get status. Oh, okay. So now it's committed. And now, but it says your branch is ahead of main by 1 commit. That means my local changes that have been committed are out of sync. So it says I should do a git push. Let's do that. So now there's my git push. If you might have been prompted to not do that. If it does, you might have had to do git push -u origin main. We already did that last week, but you may have to do that on your first push. And when you do that, you can actually go ahead and open up the repo. I'm going to open the repo from the command line just for fun. View -w. This will actually open it using the command line. And this opens up my web browser, and you can see there is, this is just a test repo, and you can see here is an empty file. There's no code in here, right? Let's pretend for a second that the code were being written here. This is kind of a Git review. I'm doing it really quickly. Let's pretend I actually wrote the code here for some reason, or somebody else out on the internet was editing this file. I'm going to edit it here. You would never do this, right? But we're good. So they put echo hello, commit changes, update hello as me to the main branch, commit changes. We're not going to get into why you would never commit to the main branch and all that, but for right now. And we'll close this down. So git status. Now watch. So when you come to the project, it's probably a good habit to do this, okay? So even though there's really no reason to do this for now, I'm going to suggest that you build this into your habit. So the habit is when you come to a project, you should immediately do a git pull. Every time, because you just don't know. It's just a good habit. If you do a git pull after already pulling down a thing, it's just going to say, nope, you're already up to date. It is getting obsessed with that habit when you sit down to do a coding session is going to save you the hassle of a merge conflict one day. Okay, so just get into the habit of doing that as your workflow. You get down there, you do git pull, and you can see, I got the changes here, right? So now when I look at my hello program, hey, I got stuff in here. And we can run our program, and it will work, right? This is nothing we've done so far. It's something we haven't already done, and we're using the echo statement. So let's talk about the echo statement for a bit. Let's actually, if you wanted to know about echo, what could you do? Pause the video. I don't know how to use echo. Where would I find out about it? Man echo? Oh, okay. What's this? All right, so you can read all about man echo in the man page. How else can I find out about echo? What are the 2 ways to look up help about bash? The other way is help echo. So if you have, and in this particular case, both of them are relevant. All right. And it's probably worth noticing. We're talking about what are some differences between bash and shell. And we talked about this, okay? But one of the important differences to note here is that many of the commands, I'm going to try to say this as succinctly as I can. Many of the commands that were separate under POSIX shell, which we talked about a few days back, are now built into bash. And one of those commands is echo. Okay? Okay, that's I'm just gonna stop there. Okay, so what they did when they made bash is they said, hey, there's really no reason for this to be a separate command. We're gonna stuff it into the main thing. And if you actually want to know, one of the reasons that the type command is so important is because even though which echo says, oh yeah, we have an echo binary, when you're using bash, you're not using echo. Right? This is why the type command is so important, because that tells you exactly what you're using on the command line. It says I'm using, so even though there is an echo binary, when you type echo from the command line in bash, you're not using it. And I promise you this will trip you up someday. Someday you'll be like, like you'll make a command that's got the same name or something, and you'll be like, well, which one am I even using? So all which does is shows you a binary if it even exists anywhere in your path. Whereas type will show you the exact thing that's being used. Let me give you an example of this. So links. So as you can see, links that's my script. Links is actually a script. But inside of links, there's also another links that's out there. Here's another one, schmucks, right? So I've been using schmucks, right? Which schmucks? There's no schmucks in my path. It's not a script. It's an alias. So get used to using the type command in order to identify what something is. And just know that POSIX shell uses individual binaries that have to be executed outside. In other words, it's little teeny tiny programs that all have to run independently of one another, as opposed to one big interpreter like bash running that just uses that as a part of its syntax. By the way, what does the word syntax mean? What does the word syntax mean? What is syntax? Anybody want to take a stab at that? Let's ask ChatGPT. What is syntax? All right. Language structure. I'm just going to keep reading from the chat here. What is your... Some people know what it is and some of you don't. Nothing wrong with that. I want to see what you think of it. I'm going to use these words a lot, so I'm going to define them while I use them. So syntax refers to the set of rules and principles that govern structure, formation of sentences or code in a specific language. Language, keywords, and structure. Good. I think it's important to note there. Did you notice how it says formation of sentences or code? Now, being a polyglot, both, technically and in natural language, I find this very wonderful. In fact, I would go so far as to say that I believe that my coding and I speak Russian and French, in case you don't know, and I got a degree in Russian. My obsession with languages, including Caribbean Creole, I believe that being able to understand syntax and structure and the rules governing communication and sentences and code cross over. I believe that. I would love to do, if I were to go back academically, this is kind of a sidebar, but if I were ever to academically go back and get a PhD in something, I would specifically study the relationship between the spoken language of individuals or languages and the quality of their code and their ability to write code quickly, and to understand the structure of code. My thesis would be that, kind of like Arrival. There's a movie called Arrival where, spoiler alert, turn it off if you don't want to get spoiled. But the spoiler alert, the more these linguists learn how to communicate with these aliens, the more their brains get rewired to understand, interesting things, we'll say, that these aliens only understand. But the aliens have to teach the humans their language in order for their brains to be rewired, which I find absolutely fascinating premise. better linguists would generally understand better code. That is something I know. People who are linguists are pretty good coders. I've heard. Yeah, I think I don't know. Anyway, I can geek out about this all day. I'm not going to. In programming, syntax refers to the correct sequence of a format of element statements and symbols, um, according to the rules of a programming language being used. Ensuring proper syntax is important and enables effective communication, accurate program execution. In language, syntax involves grammar rules. In Russian, we have declension. It's a much more complicated language. Anyway, so that's syntax. What is syntax? We got that down. And so when I say, so the reason you need to know this, because you're going to be, now that you're entering into coding, you're going to be given syntax errors all the time. And what that means is that you're violating the rules of the language. And we already talked about interpreted languages, but I need to hit on this a little bit more. Okay, so let's open up our hello program again in VI, which we already covered. Um, so, um, by the way, what language is this? We covered that. What language is it? It doesn't say a language, Mr. Rob. How do I know what language is running? There's no extension. There's no suffix. Oh my God. We covered this. What language? It's using the default language of the shell. All right. And we showed this. There's another video where I showed this, where I put Python code in there, and it's like I don't know what to do. Right. So we already did the shebang line. So just pause the video and repeat. This. If you need to go back and watch the 2 weeks ago, we talked about the shebang line. The shebang line tells the computer, so to speak, that if it sees the shebang line as the first two characters, it's like, oh, here's a helper about what to do. And we already did this, bin bash, right? We're going to do bin sh, actually. So bin sh is POSIX shell. You can reopen that. You'll get your highlighting, possibly. You can see that I'm getting a bunch of shell check errors. That's what these going crossbones are. These are shell check errors. Okay? Literal car through TR. What? Why is it mad at me? So we already talked about shell check. We're going to review that again. So we already talked about shell check. So shell check, you can run that against your program if it's not integrated like mine, and it will tell you the lines that have problems. Literal carriage return. Run script through TR dash. Why is it doing that? That should not be a thing. Set list. With ChatGPT, it's a thing that I made. Yeah, I did a video on it. We covered that when we did link stuff. Something is not right here. Yeah. Yeah, this is it's very interesting. Yeah, I think this happened because I wrote the line. I did the thing on GitHub. This is not normally a thing. This is not normally something that should happen. There is something misconfigured in my GitHub. This is new. I'm glad I hit this. Okay, so what's the error that it's giving me is that it does not like the line endings. So you can't see it, but at the end of each of these lines is a special invisible character that says, hey, a new line is about to start. And we talked about teletype a long time ago, carriage return and line return, / /r. And it's giving me crap right now because it thinks that there are /r's on there, but there are not. So I'm kind of intrigued by this. I'm actually going to remove this program and make a new one. Touch hello, bin sh, echo hello. Save that. See if it does the same thing again. TMUX hello, which is just chmod plus x. And now it doesn't have the error. Interesting. I wonder if it will detect any changes. Git status, git diff. We're going to go look at the changes. So we made some changes. Let's actually do a git commit. I mean, you normally would not commit this, but let's do it anyway. Git, and now you don't actually have to do the add anymore, right? So you can do git commit tab hello -m add shebang line. We're going to be kind of absurdly annoying with our git commits to get you in the habit of doing this. But we're going to do that. So git status, git push. I believe the reason for that is because the file was created on GitHub without any content in it before it was actually saved. That is an interesting bug I have never hit before. I am almost positive that is the reason for doing that. Like they're trying to sell you a GitHub Copilot. No, you don't need that. So that is fast. In fact, that is so interesting. I'm going to actually I'm going to indulge myself with a little test here. We're actually going to make a new file using nothing but GitHub and see if it creates a Windows-based file automatically. We're going to add a file, create a new file, and we're going to say echo hello, and we're going to save this file. Where is the preview? Why is it not saving? Oh, whoops. Testing. So I forgot to give it a name. Commit changes. Commit testing. Commit directed to main. Create a new branch. No. Commit changes. All right. So let's see if now that doesn't have anything in it. So I'm super curious to see. So let's do git pull. And that is going to pull down our latest file. I know I didn't put any new lines. Did the other one have new lines in it? Look at that one, didn't have a problem. Yeah. BinSH. This was not having a problem. Interesting. I kind of want to figure out how to do that. So that one doesn't have a problem. Remove testing. This is kind of a good practice, right? Git commit tab testing remove testing. Git push. We got to do one more test. This is super fascinating. This is a curiosity that I have not seen before. So it seems that I actually think it might be a bug in GitHub's editor. That's why I'm kind of running this down. So let's add to now. To be fair, how did I do it? I created a file that was empty, opened it and added a line to it, and then I went back. So we recreate those steps exactly as I did. Let's do that. So let's say another test. Git add another test. Git commit add another test. Git push. We're not going to use user being env. We're going to talk about that. We'll talk about that. And we talked about that last 2 weeks ago, but we're going to talk about when to use it and when not to use it. We already talked about that, but I'll hit on that again. Refresh. Wait, did I push? Okay, there it is, okay? So there's another test. It has nothing in it, 0 bytes. And we're going to go edit the file, and we're going to put echo. I'm trying to recreate that error, that bug. Commit changes. Spaces line 2, no wrap. Commit directly to branch. All right, now I'm going to git pull. And via another test. And put a shebang line in here, BinSH. I'm going to close that and then reopen it. Look, we did it. Set the core EOL attribute to the repo. It looks like it does. Look at that. This is interesting. So it only happened, that only happened when I committed an empty file, and then I went into it and edited it on GitHub, and then I pulled it down. That is extremely fascinating. That is definitely a bug. Hands down, that is a bug. So yeah, so I'm not going to dwell on that anymore, but now you know. I know it's strange. Everybody on the chat, the Twitch chat's like, oh my God, that's so weird. But this is why I do live streaming, because we want to hit these weird things together so you can know about them and you can sound like you're cool to other people who don't know about that problem. Git, was it Dell or RM? I can't remember. Another test. Git status. modified. Get. I mean. Okay, wait. So let's do this. Let's try it. Let's see if we commit it. If it fixes it, that would be cool if it did, right? Try commit. Git push. I'm just curious because if we come up here and we refresh this thing, right? Well, look at it. See, it's fine here. Open symbols panel. Edit in place. Open with dev. Blah blah blah. Yeah. I'm gonna. You guys, I'm sorry for the geeking out, but this is like, I have to know how come this is doing this. So now let's do git pull. Another test. Now it's even got more bad lines in it. Wow. Wow. Git status. Git commit. Delete Bork. Another test file. Git push. And we can move on. Well, we burned up like 5-10 minutes on that, but that's okay. So yeah, this another test should be gone. Wait, how come it's still there? Did I not commit it? Oh, damn it. Okay, git commit. Remove another test. I always forget to commit. They're not staged? Fine. Git push. There. Now it should be gone. Yep, okay. Well, we learned something. We learned something very weird there. That was very weird. It's replacing character and line read. Yes, that's exactly what it's doing. But this is important that we talk about this. So let's talk about echo, since that's kind of a good lead-in to this program, right? So there's a difference between git, echo, and print. So echo, by default, prints the thing and then prints a line return. So you can say echo hello, echo there. All right. And you can do run echo, and you see it goes hello there. It has an implicit line return that it prints out there. And that's sometimes annoying, right? And there's another command called printf, and there's a bunch of cool things about printf we can do, but most of the time echo is going to be enough for you, right? But let me just show you the difference. So if I do printf, and I do hello, and then I do printf there, and yeah, there's no quotes or anything. We're going to get to that, I promise. I want to kind of keep it really simple. So see, you see there, printf doesn't put that line return in there. All right, and if you want that line return on printf, you have to add it. And so this is our first encounter with what are called escape characters. Okay, and we're going to talk about variables and all that stuff later, but escape characters are backslash sort of sequences, right? And the most common is backslash n, but when you add it, you see that shell check's like, you can't do that. You can't just put that on a bare thing, because we need to put all of these things together inside of what's called a string. Okay, so and a string, you can think of a string as being a bunch of letters and numbers and everything on a string, like an actual necklace or a bracelet. And the knots, there's knots. The quotes are the knots. They're the things that hold all of it together, right? So all of those little individual characters or runes, depends on what you call them, emotes even, those are all on the string, and they're bound on either side by quotes, okay? That holds it all together. And if you get into C coding, you'll see that, you'll understand how that, because C does not come with strings by default. I mean, it sort of does, but C is such a low-level language that you literally have to say, okay, I want these things together, and we're going to talk about what each of these things are pretty shortly here. But I want to get this first program done so we can get to that point. So each of these characters, and in this case, these are characters. I'm going to be very precise with my language here. A character or a char is very specifically 8 bytes long. I'm sorry, 8 bits long. It's a single byte, and we're going to talk about that next, I promise. And that's where C comes nice, because this backslash n is kind of like a character. It's not, right? It's called an escape sequence, or a terminal escape sequence, and we'll talk about that. We talked about the teletype origins of the terminal already before. Please go back and watch those videos. But just as a reminder, these special escape sequences, when the terminal is printing it out, and remember, this is not a terminal. This is a terminal emulator. People have dropped the word emulator from when they refer to terminals now. When we refer to a terminal these days, we usually are referring to a terminal emulator. But I want everybody to remember that this thing that we're typing into right now is emulating what was once an actual physical terminal. And go back and watch the video on that. It was one of the first few days. But that is why we have these legacy things, right? So this backslash n sends a sequence of ones and zeros to the terminal that tell the terminal, make a new line. And you can imagine a typewriter going along, right? And it gets to the new line and it says, okay, go, we want to have a new line. Boom, right? And the reason that Windows and Unix and Linux and Mac are different is because there was actually 2 of those fancy sequences that used to be sent back to the teletypes back in the day. One of them was a carriage return, and the other one was a line return. Okay, so a line feed. I'm saying it wrong. Okay, and the reason that Windows continues, and that the definition of the TCP/IP HTTP headers, for example, is carriage return line feed, is because that is the sequence that was most frequently set in the old days to the terminal. It wasn't enough to just say, I want a carriage return and a line feed. I actually called the backslash n wrongly a line return. That's not what it is. It's a line feed. So the carriage return is the thing that causes the carriage to go all the way back to the beginning of the line. And the line feed was the thing that caused it to advance by 1. All right. Now, in order for you to understand, you don't have to put in parentheses around it, because this is just shell. There's no need for parentheses, because in shell that's not needed. Some of you code it in other languages might need that, but that syntax in shell does not use that. And this is important because when we haven't talked about arguments that we will. So this sequence says right here, print that carriage return and line feed. Now this is going to get what is a carriage return and a line feed. And we actually hit this. I'm kind of glad we hit this. So you have to have a little bit of a history lesson here, right? I mean, most people that cover this topic are just going to say, just put a backslash n at the end. And they're not going to tell you why. I'm going to tell you why. The reason is because some years ago, decades ago, terminal emulators kind of agreed that, okay, our end of line marker is going to be a line feed, right? And you cannot include these special sequences inside of a string unless it is wrapped up in a quote. Otherwise, you can in shell. Now, any other language would obviously bark at you. If those of you who learn Python and JavaScript, like, what the hell? You can actually pass arguments, they're called. We'll get there. Without it, you can. You don't need them. And that's nice because it's just designed to be run from the command line. So, but some of these things, even though you can do them, it might not be a good idea, right? So that's why we have shell check to help us out. So now when I run hello, you'll see that it does the right thing, right? Now you'll also notice that if I do carriage return line feed, is it going to do the same thing? Yeah, it is. Because historically, carriage return and line feed is the proper way to cause an actual terminal to go to the back to the beginning of a line. Now, make sure your ears are on here, okay? In the 1990s, in the 1980s and the 1990s, when terminal emulators were still being created, there was a big controversy because every one of the major computer makers was doing it differently. And I don't know how old some of you are, but does anybody remember Mac? In Mac, you would send this, just a carriage return. On Windows, you send a carriage return, a line feed, and you still have to do that to this day. And on Linux and Unix, you send only a line return. Hey, Malibu. A line feed. All right. So you're going to see all kinds of combinations for this. And in Go, I actually, so the general way to go about doing this is to do this, which is, that's a regular expression, but it's to have an optional carriage return followed by a line feed. Now, that was like 10 minutes on carriage return and line feed, and I hope that that helps you to think of your terminal as a terminal emulator all the time, because when we start to do color and stuff, and why do you care about that, right? You do want a pretty prompt like this with colors in it? You probably do, right? So if you want to have a pretty prompt like that, you have to understand that your terminal emulator is emulating a terminal, and it just so happens that some of the things that it's emulating now are changing the color of the ink, so to speak, which you're not really doing, right? Or sending, the to a new line, or backspacing over the last character, or blocking it. All of that stuff is necessary for you to understand if you want to actually start to have fun with your terminal, instead of like reaching for Oh My Z Shell or some library that does it for you. And it's really important that you understand how your terminal works, in particular line endings, which we just had a very good lesson with. We just saw firsthand that GitHub is getting the line endings wrong. Now, I don't want to get into it, but Git itself does quite a bit of magic to make sure that the line endings are all going to work on the given system that you're on. And sometimes they can do the wrong thing. That's what actually happened. So I don't know if you saw all those like skull and crossbones that I had earlier, but the reason for that is because the file that got saved by Git that I pulled down actually was a file that thought it was encoded for Windows. And by window encoding, what I mean is that the invisible line return endings, in music category. Yeah, I'm sorry. We'll change it to software and stuff. Yeah, that's because I'm restreaming. If you want to change my category right now, but we can take a break and change that. Okay, so Control R, Control N, and so long story short, on Linux and pretty much the whole world has decided, including Windows and Mac, that we should just use line feed these days. Okay, so all the major languages just use a line feed. Very rarely will they put a /R. Most languages will understand a /R if it's there, but when you're ending a line, you should put a line feed on it. Okay, so and we'll go ahead and put that there. We're gonna go ahead and do that. So we do hello there, and we get that, right? And there's nothing going on there. By the way, if you ever actually see weird characters in your file, that is because you've opened up a file that was made on Windows, and especially if it's a Control M, if it's got a little caret and then an M at the end, that's because your file was made on Windows and has somehow made its way onto your Linux machine, and it has not been converted to do the other thing. So 9 times out of 10, you're not going to have to worry about that. But this has been the best time to tell you about the carriage return line feed. Okay, I'm going to pause and change my category. We'll be right back. If you want to take a break, please do. I'm going to turn the music on. All right, we're all good when we changed. We're also streaming to YouTube again. We, for some reason, weren't. Just in case you're wondering, I am streaming to 5 different places right now, but the normal YouTube location is good. All right, so we talked about carriage returns and line refeeds as being the first escape sequences that we've learned about. We talked about strings. What is a string? And I guess I'll put that in quotes. Carriage return and line feed. And we talked about that. Now, where am I set to travel and outdoor? The Kit category I have no control over. People, but my mods on Kit can change it. Okay, so please, mods on Kit, if you're over there, please change it. They can actually change it. So we have our first sequence, we have our string, and you can see the coloring is showing us the right thing. The big change I wanted to show you is that you're printing things to the screen, and that's where the term print comes from, by the way, right? Obviously, we're not printing something to a file, to a piece of paper, so to speak. But the term print remains because of the whole terminal emulator thing, right? So we are printing things to our terminal, and that terminal emulator is doing the same kind of thing it would do if it was paper, but there's just no paper. So it didn't save. We're not going to talk about the Pomo timer right now. I'm in the middle of a boost. There's all kinds of stuff for that. So echo hello there, echo hello there. you can see the difference, right? Printf needs a line return after it. You can actually combine these, of course, into one. So let's try that. /hello. And you can see it's hello there. But that last line needs a line return, right? It needs a line return, so I can put a line in there. Oh, you know what else I noticed? My key echoes are not working. Why are they not working? Yeah. There we go. Okay, so there we go. I just wanted to put that up on the top right. So we have hello there. We have /n there. And we have a hello here. This is implied. So that has the character line feed. Both of these, by the way, type printf and type echo are shell built-ins. All right. Now, if I were going about a proper education on software development, I would spend an extremely large amount of time talking about memory and how things are organized and state. We're not going to do that. We're going to keep things very practical and here's how you do a thing, right? To understand all of those low-level things about state and all of that, if I cover it, it will be covered in the C class, the C course that I'm going to do as a part of Head for C, where we work through that. If you want to really understand those low-level details. Right now, you just want something to work, right? And therefore, this is not sufficient for a computer science course. That's where you would maybe learn all of those kind of things, the design of computer languages and stuff. You just want something to work. You just want something to print to the screen. So that's how we're going to do that. And okay, thank you for the change. So we've done it. We did our hello programs, right? So the traditional hello world. Why is hello world so popular? You can ask ChatGPT. Why is hello world always the first program coders create? Let's go ask ChatGPT just for fun. While ChatGPT's thinking, we'll go fix this up a little bit. And let's actually, instead of saying hello world there, well, let's say hello world. We'll put an exclamation point in there. Oh my gosh. Why is hello world is often the first program they make for a few reasons: simplicity, testing, it's easy to test, tradition, debugging, and a milestone. For programmers, hello world is their first exciting milestone. So that's right. Everything ChatGPT said. CMDS. Okay, so this is it. We have hello world. We made our first program. You actually made a program that's much more complicated than that. The takeaway from this is that putting things that you can do from the command line into a file is the same. So printf hello world, right? Oh, I put an exclamation point in there, right? Aha. This is where things get really interesting. So the exclamation point has a special meaning to programs on the command line. And I'm really glad we hit that. So world. So we have to tell it I actually want to use an exclamation point. Hopefully this will work. There we go. Whoops. Nope. Yep. Exclamation point has special meaning to the shell. Yeah. Huh. That's interesting. Huh. How do we do that? Okay. So let's say, why does exclamation point have special meaning to the shell? Exclamation point has many different uses on the command line shell that I don't want to deep dive into right now. One of them is to reference other commands. So when you're using it interactively, so the statement, everything you're putting in a script can be done from the command line, has a couple caveats, and that's one of them, right? If you're going to do that, you need to not do that. So in shell, you can actually combine your strings together and have them be two strings, right? So, and there's also another way to do this, is that you can, instead of using, it's just kind of a different knot on the ends of your string, right? You can use single quotes. Now, every language is different here. And I'm just going to put that out there, right? Every language on the planet deals with single quotes and double quotes and backtick quotes differently. And we're going to see that as we go, but we're going to learn the shell version first, and you're going to see how that transfers over to the other languages later if you want to do that. So by most languages, however, single quotes mean, look, I don't want to do any escaping. I want it to be exactly as I have it. I do find it interesting that \n still escaped on that. That is very fascinating. Yeah, that's pretty interesting. Yeah, look at that. It still did the \n. So let's actually go read about that. Help printf. Let's read about it because it's doing something that I was not expecting. So it returns this. Let's see. Here we go. Help printf. Here we go. So printf formats commands the arguments. We're talking about arguments are all the little things that get passed into the program. You can think of a function as all the stuff in parentheses, except for there's no parentheses. Format is the character string, which contains the type of objects. Plain characters, which are simply copied in. Character escape sequences, \n, which are converted and copied to the standard output, and formatted specifics. All right, so in addition to the standard specific in printf, we also do these special things. So printf has some cool things we're going to do later. But let's try that command again. So I just think it's interesting that it's doing the carriage return. So here we see that the \n is still working, it's still being escaped, even though it, it's a thing. Now, if we were going to do that with Perl or Python or something like that, then these would actually be, or Go, these things would actually be printed as a \n, exactly as they are. To get an actual \, you do double \. So how do I escape a \? And this is going to get really hairy and shell. This is one of the reasons that people like just shudder when they tell them I'm learning shell as the first language, because of these kinds of exceptions, right? So I could have done that with double as well, and it's like, what? I don't know what to do. Actually, let's do this. That's still not liking this right here. Yeah. Printf just doesn't like that. I wonder what echo's going to do the same thing. Okay, there we go. So it looks like echo and printf have different behavior. That's what I kind of would have expected. See, echo doesn't have the escapes. It doesn't do the escapes. It can, if you do -e, it'll do the escapes, but that's not POSIX compliant, so don't get used to doing that. And you can do echo like this, and that will actually give you exactly what you expected it to be, right? Problem with that is, then how do you do line return? Well, you'd have to do another echo, to get the stuff that you want, and then you get what you expect, right? So it's two different echoes, but this one's, if you want to get rid of the line return, you do -n, which on here you can do echo -n. Hello world, and you can put them together. There's another option you can do here, printf. You can actually put them next to each other. So you could say hello world, exclamation point. And now you get the thing that you wanted, right? So that is another way to do it with the printf in there. But now we're using single quotes, right? So take some time, stop the video right now, and play around with all the different ways that you can use printf and echo from the command line to print things out, okay? And understand the differences between colon and double quote. So if you want to dig deeper, as I said, you can do help echo will tell you all the different escapes that you can use, including color escapes, which we'll get into a little bit later. And then you can do help printf, and that'll show you the other reasons to do that, right? And there is one other major advantage to using printf that I'm going to talk about that is going to absolutely drive C coders and any other Go coders and everybody else crazy. But it is a really important sort of side effect of printf. Okay, so what happens when I, let's see, what is an argument? Okay, what happens when I add multiple arguments to printf? Okay, and this is actually a really powerful thing. So, and it's a very shell specific thing. If you have printf, right? Normally we talked about printf. Printf is like, so one of the things that printf does is it allows you to put here. Let's see, hello. We're actually writing another program here, right? So we could say hello, hello v. We can say let's do it like this way first. Okay. Actually, let's do this so we get our line return. Hello world, right? Damn it. I got to figure out how to escape that from the command line. It's, yeah. This is fun. I'm glad I'm having a problem with this. Yeah. I mean, if we put it in a shell script, we're not going to have problems. So maybe we should just do that. Should we just stick it in the shell script and just be done with it? That's why, because if it's in the shell script, it's not a problem. See? All right, let's do this. Hello. I'm kind of glad that happened, though. Hello, dash world. Okay, so that will work. /hello. I don't know why this. I mean, that exclamation point only affects the interactive shell, apparently. So that's good. But let's stick with this. I don't want to get too bogged down on that. So let's stick with how to do the code, right? So here's the advantage of hello world. Instead of saying hello right now, whoops, /hello, it's going to give us hello world, right? But what if we wanted to make world something else? We want to have it detect our user, right? Well, here's something really kind of fun. So there's actually a whole bunch of environment variables that are already set. And one of them is, so we don't know what variables are. We talked about them briefly last time, but these are placeholders. You can think of, when I teach about this to little kids, I use like a hat or a box, okay? A variable is kind of like a box, and you can put one thing in that box at a time. And if you put something else in the box, the other thing gets dropped out and it goes away. Okay, so if you know algebra, you already know what a variable is, right? So f of x equals 2x plus 5. X is a variable. That means you can vary what goes into x. That's what a variable is. Okay, so, and arguments are variables. What is a variable? And variables provide state to an application if you want to get fancy into computer science terms. But why do you care? The only thing it does, the only reason you care is it lets you substitute things in other places. So that's the practical application of variables, right? And we're going to extend, on that idea. I'm not going to bog you down with too much more of that. Well, some of these variables for us have already been set, okay? And they have a very specific name. What are environment variables? Or system variables. And I think Windows calls them system variables. These are variables that are available to you to use from any of your scripts, okay? And you can change them, and they are the method of communicating between applications that are running in the same session or under the same, parent session. Environment variables, fun fact, were also the primary way of passing data from web pages in the 90s under a common gateway interface. In other words, when people would submit form data or they would do query strings, those little things at the end of a URL that come after the question mark, that stuff would go to the script, and all of that stuff would be set as an environment variable for the program running in order to pass data from the outside world into the program. And it goes without saying that that's a really great way to hack something. In fact, one of my favorite things about Bandit when I hacked it is I actually hacked an environment variable that's passed from the remote system to pass one of the levels by overcoming that particular system's default setting, because it's using environment variables from an untrusted environment. So, so knowing about environment variables is the thing. Environment variables are also the core way of passing specific customizations of a container, a cloud app. So in the cloud world, we run containers are called. These are these containerized applications, and they're designed to just be cookie cutter. And so at a macro level, being able to run one, you have to be able to pass environment into it to tell it, maybe what web server to go look at or whatever. And so those environment variables are set for the whole container, and that's a way of transferring the data. So it's very important that you understand what variables are, arguments are, and specifically environment variables. And your system comes with a bunch of environment variables for free, right? So my env is going to be broken because I have a lot of color in here and stuff, but yours probably isn't. So if you type env, and this is going to lead into a conversation about what env does. We already talked about it, but we're going to talk about it again. So what does env do? Env shows you your variables, right? But and if you want to, you can kind of like, get them all out of there. I'm not going to show you all of my environment variables because I may have a token or two in here. I think it's extremely bad form to put secrets in environment variables. I've said so many times, but several applications do require that. There's ways around that. But and as you can see, these fancy functions and stuff. So Bash actually saves functions, which we haven't got to yet, as environment variables, which was the basis of the biggest hack in history on the Linux platform. Bash door, otherwise known as shell shock, which is referred to in Mr. Robot and a bunch of other things, just as a fun fact if you want to go look about that. Because people were overriding behavior in the shell by setting environment variables, because Bash uses environment variables to store the code of a particular function, which we haven't got to yet. But so let's go ahead and clear that. But now you know what environment variables are. So echo user. So user is one of the many standard environment variables that are defined by POSIX to run on Linux and Unix, and they're everywhere. Another one is PWD. We're just using some of the most common ones, right? These environment variables are going to become very valuable to you later when you start writing and customizing your bash RC shell script, your configuration file. And that is coming. The reason we're learning a little bit of shell now is so that we can learn enough of it so we can write our own customizations, including our prompts and our other things. And so understanding these all caps environment variables is critical. If you don't know that, you can't customize your shell and manipulate it in that way. And I've created environment variables for many other things. I think I have one called repos. Yep. So, and then my scripts can just know that those environment variables are going to be there, so that all my scripts can use those same environment variables. But returning to the idea of variables. The idea of variables is also localized. So, let's see here. So so you can also use variables within code. And so here we have hello world, right? Well, let's first of all try the environment variable that we just learned, $user. All right. And it says here, don't use variables with this. All right. So to get this to shut up, I'm going to comment it out. So how do I use comments in shellcode? All right, so we're going to use comments here. So what are comments? Comments, anything beginning with a hashtag, are automatically ignored in any shell, and they can be one or two. I generally use one because if you use one and you write a bunch of stuff, right? Your shell code, you see this now how big it is. You can actually do GW and then write. Is that it? Why is it not working? Oh, here we go. You see what I did there? Yeah, you can do GW, and that will actually wrap, and it will put a new thing at the beginning. If you do it with two, it doesn't do it. So anyway, you can use comments as big, long explanations. You can also use them to disable code. Very, very common in every single language to do that. So we don't want that one to work because it was complaining, and I'll tell you why in a second. But let's do the exact same thing, but let's use echo instead. So echo is going to give us a line return for free, right? Let's try echo instead. So let's do that. /hello, and we get hello RWX Rob. See what it did? It grabbed my variable from the environment, right? Now there's another place you can grab the variable from, we can make a variable. We could even say if we wanted the variable to just be in the script, which is kind of stupid, right? Because we want to grab it from the environment. But in this case, let's just, for the sake of giggles and grins, let's just go ahead and do it. Let's say user. Okay, so we could say user equals. And by the way, this is going to annoy people, but in shell, you can never have a space after or before the equal sign when you're assigning variables. It's a syntax error. Let me show you if I do it. So I'm going to get an error that's like, uh-oh, death. You can't do that. So I want to say RWX Rob, right? Or just say Rob. Okay, so it's going to tell me can't do that. How am I doing that? All those little things. Just do colon. If you do shell check, if you don't have Vim set up to do this, we did cover how to set this up in Vim though already. So you can look at my vimrc if you want to add these kind of prompts. So user equals Rob, and it says the error down there is getting kind of truncated, but you could actually run a shell check on it to get the error, and it says user appears unused, which is great, right? You don't want variables that don't get used because nobody will know what it does. So let's change this to user, and now if I save it, you'll see the warning goes away, and we can run actually the warning goes away. There we go, and hello, and we see it says hello Rob, right? All right, so now we're going to set up a little test environment. You see how I kept having to go in and out of the program all the time? Kind of annoying, right? So we're going to spend about 5 minutes. We only have 15 minutes left. We're going to go ahead and we're going to split the screen using TMUX, which you should have already practiced a lot. We covered TMUX already. We're going to split the screen. And so I'm going to do Control A dash, and that's going to split the screen. So now I'm in the same place, right? Or am I? No, I'm not. So down here, I need to go get to the same place. So I'm going to go into boost dash test. And you're like, how did I get all the way there? I use something called CD path. So if you have to, you can like go there the hard way. I'll go there the hard way right now. So let's go to CD / and then tab. Let's see, where do I go now? Repos, tab, github.com, tab. Let's go to, which one is it? RWX Rob, tab, boost, tab, and tab. Now, okay, so now I'm there. So now I can go all the way there, right? If you want to go back to where you previously were, CD dash, and then CD dash, you can go back. If you want to go back to your home directory, you can always just do CD. We've covered all of that before. So now I'm in the same directory. I have two panes. There's a little line between them here. I mean, I'll put the fishies down here just so you can see. And up here we'll do Neo or something. C matrix. So here you can see I have two different panes running, right? So down here is there's two panes. And up here is another pane. And usually I'll have two windows instead of two panes. But in this particular case, I can get away with two panes. What the goal is I want the pane down below to run my program every time I make a change. And that is the goal and purpose of the entr command. Man entr. Run arbitrary commands when a file changes. This is one of the most amazing programs ever made. It will run whatever you tell it anytime a specific list of files changes. So we're going to do that. We're going to do entr. And because it does not do well with lots of commands combined, we're actually going to run a shell. The one command that we're going to run is bash. And then we're going to run -c that says to run this program. And we're going to put in quotes, we're going to clear the screen and then put a semicolon, which is the same as we're making a little script. Okay. And then we're going to say that we want to run this, we want to clear the screen, and then we want to run /hello. Okay. And we want to do that anytime that file changes. So the way to do that right now, just trust me on this, we're going to learn about it, is to put three of these and then do hello. All right. So anytime the hello program changes, let me do that again. So entr --c clear hello. The --c allows us to have two commands combined into one. It's like a miniature script. And this says send this string hello as if it were in a file to the standard input of the entr command, which takes standard input. You don't know about that yet, but that's what it does. So just trust me on this part for now. And we're going to push enter. And now you can see this. Now you can resize. So I'm doing Control A, JJJ, Control A, KKK. Go back and watch the TMUX if you want to do that. So we can actually have that run every time that file changes. And I can go into the hello program and I can change my variable in real time. Hello Doris, save. And now it says Davis, hello. there. I mean, we can put the word there here. And it changes it to hello there, and it runs the program as we go. Okay, so that is the advantage of that. So hey, yeah, welcome everybody. Um, put a space after the exclamation point and your printf. Really? Did not know about that. Okay, so that's it is pretty sick to have your debugger there, right? People ask me all the time why, but that's if you want to run something testing, you can do that. Okay, and by the way, that can be recursive. That can be you can say if any file here or below changes, and we haven't got there yet, but we will. So there we've got a local variable. Okay, now this is a local variable that is being changed. It's not being pulled from the environment. We can go back and change to our other thing before here. Let's go back to change our printf, save it, and you'll see that it is now doing the user one, and it's giving us a warning though. It's like it's telling us some stuff about printf that I wanted to come back to. You wish you know about ENTR earlier? Me too. There's so many things about shell that I continue to find out, even in my 50s, that I never knew. It's like, just be prepared to be discovering. It's one of the wonderful things about Unix and Linux is you never know it all. There's always more to learn. There's always some cool little thing around the corner that you can find out and share with your friends, So there we go. So we have the printf function here. This is somebody in our Twitch stream is a veteran, and we get veterans in the beginner boost a lot who are very helpful. Thank you, by the way, everybody. And they frequently will find something out, which I always love because that happened to me since I started streaming. I've had people share so many things with me. They're like, "Did you know about this?" Right? I'm like, "No." So no shame there at all. This is saying, "Hey, you're doing this wrong," right? And if you want to see that full message, you're gonna have to go out and run shell check. Another thing too you can do here, actually, if you want to get really fancy and you want to see that instead of I'm going to show you another cool trick. So you can actually split another pane, right? Let's go back to where we were, repos, github.com, rvxrob, boost, right? Boost test. So now we're in boost test right again, and now I have another pane. So now I have 3 panes. By the way, if you lose track of all your panes, this is something we didn't learn in TMUX, okay? Before we needed to learn it. So Control A Q, and it shows you all of your panes and what size they are. All right, I should put that in the notes. So what does Control leader let's see, A plus Q do in TMUX? All right, now how about this? How do I display the size and panes in TMUX? All right, so that's how you do that. We'll make this more like a quiz that you can give yourself. And hey, how you doing? Oh, the thing at the end? Yeah, the little string thing. Isn't that great? So, and that's a bashism, by the way. I don't believe that works in POSIX, as far as I know. So, another reason to use bash, I think it works in K shell actually too, which includes Z shell. Anyway, so here we've got this middle pane now, and let me do CMatrix here just so you can see. By the way, if you want CMatrix, sudo apt install CMatrix. That's all it takes. It's really all it takes, my friends. My super secret password. Don't tell anybody. Shh, don't tell anybody. All right, so you know what? I turned my shell check off. You know what? It's because the Neo program is broken. Yeah, my Neo program is broken. Okay, so here we go. We can do CMatrix, and you guys can have a copy of it. There's actually a lot better versions of CMatrix. There's a thing called TMatrix. There's also a thing called Neo, which are way better. And I've covered those in other videos. We're not going to do that today, but CMatrix is pretty easy to install. Why don't I use line numbers? Line numbers are unnecessary to me in Vim because the line number is always available to you down here. Anytime I need the line number, I have it right here. That's the answer. Is I don't like to be distracted by line numbers. If I had line numbers in addition to everything else, I would just be distracted. And ask you query proficiency, yes. So that's why I don't use it. The short answer is I don't use line numbers because they're here. And I don't do a lot of offset stuff. So that's what's up with that. Anyway, so now here's some, check it. Okay, so you remember that whole thing about shell check? Let's say you don't have your Vim set up yet, and you want to have shell check run anytime your program changes, and you want to see all your errors, right? That'd be pretty cool, right? So let's do that. Let's do that. Let's do our ENTR program that we know, ENTR, and just for fun, grains and giggles, bash dash. You probably remember this, bash dash C, and then in quotes, clear to clear the screen, and then shell check. And then we only have one program, so shell check hello. And we're going to do that anytime hello changes. Okay? And we put that on, and now it'll tell you the errors while it's happening. Yeah. Now that's what this is, except for you can't read it because it's too small and you maybe don't have Vim set up to do that. But if you don't, you can just turn it on like that. By the way, I've said this before. We talked about shell check. But one of the best learning resources for shell coding is this wiki. I'm going to click on the link here. This wiki is so freaking good. It is so freaking good at helping you understand how to code in shell, and more importantly, how to code safely in shell. Another reason that people would really shake their head at me for teaching you shell as a first language is how insecure shell is. But if you learn how to code shell properly, so many people have never been officially taught how to code in shell, and my God, they are the most terrifying people of all. I've seen you... I'm going to calm down now. I wish I could show you the code that I have seen in production at Fortune 500 companies that was running as root on major systems. Don't be those people. Learn shell. Learn it. Just learn it. Learn it. Learn how to do shell. Okay, so anyway, I wanted to show you that this is a great resource for learning, particularly if you've got an error. If it's like, why isn't that? I mean, that seems fine to me. And it tells you right here, it says, don't use variables in the printf string format, use printf this instead. Because the whole reason to use printf, dummy, not really, but is to use %s. So let's talk about %s. So you can read about this in help printf, but what you would do is instead of doing this, you would put a placeholder. It's kind of like a little template, right? And you put a placeholder there. And then as the second argument to this program, separated by spaces, things that are separated by, let me tell you something else here. What are fields? Okay, this is a common term that's used in programming. It's called fields. Fields are separated arguments, usually, or text that is separated by usually one or more delimiters. Things that, what are fields and delimiters? And delimiters. A delimiter is something that separates something else. Okay. And a field is the stuff that's being separated. All right. The most common form of fields and delimiters are spaces, white spaces, spaces and tabs and everything, and actual words. Right. So in this case, if we were going to get funky with this, we can see we have one argument. Now, what's the difference between an argument and a field? Well, this first argument is actually two fields, right? Hello, space, and then whatever this thing is here. That would be two fields. So fields are separated generally by spaces, but not always. This is going to become important when we get into sed later, which we're not there yet, but I want you to understand this idea. So arguments, sometimes they're fields. You guys saw me doing this, right? You saw me doing echo hello there, right? How come that works? Well, because arguments, generally speaking, without any quotes involved, arguments are assumed to be fields, which means they're separated by spaces. So echo hello there, echo has been written to accept multiple arguments and put them together into a single string. And so you can use that to your advantage, like what are fields and delimiters. When it comes to the command line thing, you'll see me do stuff on the command line all the time that is just me being lazy. The only thing that's different between this and this is nothing. They're exactly the same, except for I don't have to type those stupid quotes. Okay? And we're going to get into the special variables. We don't have enough time today, but we're going to get into these special variables probably at the beginning of the day next week. But I wanted you to understand the concept of fields and delimiters because that's super important. It exists in every single language. And the important thing here is so that when I use the word argument and field, I want you to know the difference. So printf accepts one or more arguments. All right. And if it's only one argument, as you already saw, hello there, it's all fine with that. It's totally fine with that. See how the shell check is with that? It doesn't give us any errors, right? It's totally fine with that because there's no substitution going on. But as soon as I try to do this, it's like, that's a bad pattern. That's not, you should not be doing that. That's a bad practice. If you're going to do that, put user over here, right? And then make this into a substitution marker into the format. You notice that's not a different color because it's a special thing that says, hey, put this here. And it substitutes this. It's giving us another problem. And this is actually a really important error that we're getting right now from shell check. This error is keeping us safe. So this variable is coming from the outside environment. And as far as shell check is concerned, it doesn't know where that came from. And I already told you about CGI scripts, which come from the internet. So the default behavior is to not trust variables that originate from external sources. And in Perl, they used to have a taint checker. Anything that originated from an external source, in this case the environment, is tainted. In other words, unsafe. You could actually write a little program inside of that user variable, and you could take this little printf thing, and you could hijack the entire program and do whatever you wanted to. Yeah, we should maybe do that once just to show you how fun it is. It's called shell injection or argument variable injection, and it's a legitimate attack against the shell script. So how do you get around it? Well, you surround your variable in double quotes, and that protects it. That protects it from doing injection. Okay, and I'm not going to teach you how to do an injection right now. I really want to, but I'm fighting it off. Okay, if you want to imagine. Should we do an injection attack? Danger. How about that? Let's do this. Should we do an injection attack? Yeah, there's no danger. Invalid directive, printf. Wait, what? Why does it give me an invalid directive? Oh, because there is no danger? There is no danger. Danger, Will Robinson. Huh. What's going on here? Shell check is happy, but it's not saying it. Oh, did I do it wrong? It's not V, it's S. I'm so stupid. V is go. Guys, I'm so sorry. I think go is V. And so I got confused. Say it's domestic to do more than 30 lines of bash script. Yes. So here it substituted it, right? But what if we pull danger from the outside environment? Yeah. What if I got sneaky? Yeah. Export danger equals Will Robinson. All right. And now if I run, now the program down below doesn't know about that, but if I run it up here, it got it, right? Because again, it pulled the environment variable out of the untrusted environment, right? But I can get really creative here. Yeah. I could do time, or I could say echo muahaha time. I don't know if that's gonna work. Let's try it. All right, so now we run it, and you see it's all safe, right? But what? Hopefully this is I'm hacking from the cuff here, so this might be wrong. But watch what happens when I take the quotes off. And shell check is like freaking out. Shell check is like freaking out because watch. Oh, that's interesting. Wasn't expecting that behavior. So that actually did the other echo behavior. Yeah. Yeah. Let's do something else. Let's do this. Let's say, how can we have some more fun with this? How can we have some more fun with this? I wonder if we could put backticks in there. I bet you we could. I bet you we could put backtick in there. No, this is going to evaluate. Wait, we have to put single quotes around it. Yeah. I'm like, no, didn't work. I mean, I have to spend some more time on this one. But the point is, I want you to see that it actually expanded out all of those things and did it. All right, let's actually try it with echo. Yeah, this is fun. Let's try it with echo. Let's do it without printf. Let's use echo. Echo is like really dangerous. So let's do echo danger. This will be way more fun. Now that's been quoted. That's been quoted though. Let's get rid of the exclamation point and keep it unquoted. Yeah. Let's do echo and then space danger. Yeah. Now this might work. This might be more interesting. Nope, it didn't do it. It echoed the whole thing. Mm-hmm. All right. I'm gonna hack in my own code here. Let's do because it's a single quote. Let's see. It's a separate TMUX frame. I don't know. No. We have to figure out some way to get the shell. I'm not doing very well here, folks. Yeah, it's not getting expanded the way I wanted it to. Anyway, you get the idea, right? Though the idea is that you can put stuff into the variable that if it's not quoted, it'll get expanded, and that expansion, that command line expansion, is where this is the same basis for SQL injection for people attacking databases on the web, which is a different approach, but the same concept. Or anything with injection means that we're putting stuff in a place and having it behave differently than it was intended. Okay, so that's injection, and I had a little bit of fun exploring that. If you want to have fun making your own shell injection shell script and posting that in my video down there as a link to it, to like a paste bin or something, that'd be fun. You can like help me remember how to do that. But for right now, we're just gonna get rid of it, and we're gonna show you the behavior that I intended to show you, which is this. So we're gonna grab that user variable. Right now, we're going to grab it from here, and we'll put user here. Right now, I use a lowercase because it's internal. If it's an internal variable, I generally use lowercase. There's no rule that says you have to do that, but that is the way to do that. Are they patched the default behavior? Did they patch it? Did you find that out? Once in the series. Not if you watch the one on Netflix. The series has got it all over. It's for the stuff. Terminal on the lower pane. Yeah. Yeah, the stuff down below is okay. So here's grabbing user there, right? Now watch what happens if I do this. Something else. So this is very specific behavior to the printf command in shell. This is not the same in Python. It's not the same in Go or any of these, or C. This is very specific, very odd, very weird behavior in shell that can be used to do all kinds of cool things later on. So what this will do, is this for every single argument that is here over and above the number of format strings inside of the string, it will actually do that whole entire line once each time. So when I save this, now you can see that there's a lot of stuff here. Now that really weird nature of printf in the shell can be used to great advantage later when we start doing things with variables that contain more than one thing. Like like they're called arrays or slices or something, but we haven't got there yet. But when we do, that's going to come back. But I want to show you that now since we're talking about echo and printf. Okay. And obviously, if I put all of these in a quote, now it's only going to do that because why? Because it's a single additional argument. Now, if I were to put this here, now it's going to do it right because there's exactly two fields. So the syntax of printf is take the first thing as kind of our template, and then with these little template markers in here, and then each one of these different things here, we're going to substitute those in. And I am not going to get into how to make your output really pretty with printf and offset it and everything. We will do that later though. When we do our octal counting script, we will come back to printf and we'll show some of these more advanced formatting capabilities of printf, which are pretty much universal to any programming language. So So I know we spent a lot of time on print on Hello World today, and we're quickly approaching the 1 hour and 34 minute mark. So we're going to keep talking about this, but the main things I wanted you to take away today are variables, user variables, and being able to echo things to the screen in Hello World. So, but there's one last thing that we need to talk about with our remaining 30 minutes. How do I pass data into my program? Okay, so we already talked about that. What are fields and delimiters? How do I pass data and variables into my program? Okay, from the outside, and we already talked about that kind of out of turn. We talked about environment variables. So let's say this: we already talked about one really good one that's already predefined for you, user, which is predefined. Oh, we got two formatting variables, so let's empty that one. So you see, we get our program is like detecting who we are. Now, this is really important when you're starting to write build scripts and when you're starting to like make containerized applications, and you're going to want to know about how to pull these environment variables in like we just did, right? But what if we wanted to make it so that when the program is run, that it does something, it pulls in something different, right? And this is where things get really interesting. So, okay. And for this particular thing, I have to show you. This particular screen is going to confuse you, so I'm going to leave that off for a bit. And we're going to say I want to pull that in. I want the user to be able to pass that in, right? So the first, there's actually three primary ways to pass data into a program. Okay, the first way is that we talked about was environment variables. That means setting in a variable in the environment that is kind of overarching the program that's running, and then it can pull it out of the environment and use it, so long as it's been exported. And that's probably the main way to get data out of environment variables and pass it into a script. The second way that I'm going to show you is using arguments to the command. The third way is by reading input from standard input, which we're going to spend almost all of next week doing. We're not going to do that this week. And then the fourth way is to open up a file and get that data. And kind of related to that is a fifth way, loading it from a web page, like fetching it from a web page, right? So these are the primary ways of getting data from outside. There's also querying a database, which is largely related to an internet thing. And we might actually do that. I don't know. But the other ones are the major ways, right? So the first way is to get it from the environment, which we covered. The next way is to pass an argument. And if you want to think of a mnemonic device, think of args like a pirate, And so args are passed on. These are the individual fields, usually, that are coming in after the name of the program. So, and I can't run hello because I'm not says hello, but if I did, I can run it, okay? It still says hello RWX raw because it's using user, but what if I did this? What if I wanted to say hello me, right? And I wanted to have it say hello me instead of that. How would I do that? Well, that is where we get into an argument. So instead of user, we're actually going to use our first special variable. And if you want to read all about special variables, you can do man bash, and you can do var, search for var. Just keep searching variables. Where are you? Variable. I'm trying to find a good way. There's a bunch of stuff here. Restricted shell. I mean, maybe we can search for argument. Argument command string. Is it called special? I'm trying to help you find it faster. This is a big document. This is a really big document. All right, there's the escape characters, built-in commands. I'm trying to figure out what they need. Special parameters. Here we go. So they wait. No, these are not the same. Parameters, really? Okay, so instead of calling them arguments in Bash, they call them parameters. That explains parameter expansion. Interesting. Okay, I don't think I made that connection before. what are parameters? All right, so the general term parameter means what are parameters? Parameters are generally the settings or within which you want to operate, right? That's the general term. And apparently, I mean, parameters are sometimes used synonymously with the arguments that are passed into a script or a function. Parameters are variables that specify within parentheses within a function or method the order, blah, blah, blah. Parameters act as placeholders for acting values, which will be placed into the function or method when it's called. Okay, so yeah. So parameters are the placeholders, and the arguments are the things that actually go into the parameters. Okay, and does that make sense? So like f of x equals 2x plus 5. X, strictly speaking, x in that sense is a parameter. And if I call f2 equals 2, equals 2, 2 times 2 plus 1 or whatever, then the 2 is the argument. Okay? So, and you can think of if you have a machine, right? You can think of the parameters as being the slots, the coin slots, the dials, and stuff that you can set, and they all have names. And the values that actually go into those things or get set are the arguments, right? And it's actually really confusing. People interchange arguments and parameters all the time, as you can see, even in the Bash documentation and the shell check code. It says if you have multiple arguments, it doesn't call it as a parameter in that case. So the parameter is the space to put the thing, and the argument is the actual thing that's going in. Okay, so here we have ChatGPT explaining that for us. So in Bash, that's why I couldn't find anything about arguments, because you have to search for parameters, right? So I'm glad I remembered that. Special parameters. The shell treats several parameters specifically. So these are the parameters, the special parameters that you can set. And the first one that we're going to learn is the ones that have numbers. Okay, so how do I pass the first argument? How do I get the first argument into my program? Okay, so let's go back and look at that. So we want to get that first argument, and the short answer is $1. So we can replace user with $1. The $1 parameter is a special parameter, and I think it goes up to 10. I don't know. I've never used more than 10. I'm trying to find out. I wonder. Can be used in typecasting? No, it cannot. No, the dollar for typecasting is very much a TypeScripty kind of thing. That is not a Bash thing. In fact, in most shell code, Python and other, well, actually not Python, Perl and other thing, the dollar means, hey, get ready, here comes a variable. So here we go, special parameters. These are the special environment variables. Why didn't it do that? Wait, there it is. I'm trying to find it for you again. Param. There we go. Parameter. An entity. A parameter is an entity that stores values. It can be a name, a number, blah, blah, blah. Okay, so this is not true in all other languages, but in this language, you can actually use numbers to store things, or a special symbol. And this is where, again, people groan when they say I'm teaching shell first. All these special symbols and stuff make shell code look very cryptic and like chicken scratch, and it's actually why Perl gets such a bad name, because Perl tried to look like shell. and if it's not written clearly, it can be pretty hard to read. But we're gonna write our stuff very carefully so that we don't get that problem. Here we go. So $1, there's the first one. So $1, if the control variable for loop, blah blah blah. So positional parameters. All right. So the positional parameter is a parameter denoted by one or more digits other than a single digit 0. Positional parameters, 0, by the way, is the name of the program. Positional parameters are assigned from the shell's argument invoked, and they may be reassigned during the set built in. What I want to know is how high up it goes. Actually, let's test it right now. It'll be fun to test. So we already know about $1. Let's try that one. Okay. So this is it's like, well, where is $1 coming from? Well, I'm going to show you. So hello, we do hello now, and it's like, there's nothing, right? Hello, Rob. Hello there, right? Hello, Rob Muhlstein, right? It blew off the other one, right? So if we wanted that one on there, we'd have to do one of two things. We could do this if there was 2. That'll work, but it's not very, it's kind of brittle code, right? We could do, anything. I want to see if I can get like braces. What? This is new. I just learned this. Any positional parameters bigger than 9 require braces. I did not know that. My curiosity has paid off today. So I have never used more than 9 positional parameters in a shell script, ever. And so I was just curious to see if it could go higher than that. And I just learned today that yes, it can, but it has to be surrounded by brackets, which is probably an important time for us to say that we want to start putting brackets in things. So let's talk about brackets for a second. Let's see, how can I join a variable to let's see, immediately preceding a string. So this is actually, let's go back to echo here. All right, let's go back to echo. So echo, hello, user. All right. Actually, no, let's do $1. And you'll see that it's actually, my coloring is actually helping us out here. It's fine there, right? So if I do /hello, Rob, you get that. You get Rob Muhlstein. That doesn't work, but this does work. Why? Stop the video and make sure you understand what I just did. Why did it work when I put quotes, and why did it not work? And then think about all the stuff we talked about with fields and argument position and everything like that. When you put quotes around something, it becomes a single argument. Otherwise, it's inferred to be 2 different arguments. It's exactly the same as if I did this, which is completely valid. By the way, the number of spaces doesn't matter. I can have like a million spaces here. It doesn't matter, right? Fun fact, if you put a space at the beginning of your program, it will no longer show up in your history. Yeah. You might not know this. So maybe there's one command that you want to do that somebody's making you do that has like a password that's passing as an argument, which is totally stupid. But if you ever had that, just put some spaces in front of it and it won't show up in your history ever. Or maybe you don't want it to clutter your history or something. Just put a space in front, okay? And so, we've got the 2 arguments there, right? But, so let's first of all do the disambiguation with this. Now, you'll notice that the $1 shell's good with that. It's like, okay, 1 through 9, it's got a problem. I mean, but what if it was actually not that? What if it was this? I mean, it's only doing this because this isn't a thing, right? What if I wanted to say, basically I wanted it to do this. I wanted it to say Rob user, right? And I wanted to turn it into something else, right? How could I do that? Well, your instinct might be to put _user here, and let's see if that works. Rob user. Okay, that worked. Why? Because it was a special character. Yeah, but what if we wanted to say Rob dash user? Let's try this one. I'm trying to figure out. I'm trying to break it. I know that these are all going to be okay, but what if we just wanted to be Rob and capital user? How about that? We want it to be like this. You know. Now this is where things get kind of messy. It should anyway. Hello user. Hello Rob user. Man, Shell is doing pretty damn well. Because why? Because it's $1, right? Because it knows about it. It knows about $1. But watch. So if we actually get crazy and we do this is very common to do this, by the way. We want to put $1 inside of a variable called user. And now we're going to put user here. Now we have a problem. Now our shell check is kind of not happy, right? Why is our shell check not happy anymore? Because we have now, it can't tell where one ends and the other one begins. If we put a dash there, it's fine. Okay, why? If we put a dash there, it's fine because it can sense the difference. If we put a dot, it's fine. If we put an underscore, I think it's not fine. I think underscore is considered an alphabetical character. Yep. So alphabet A through Z, numbers, and the underscore are considered alphabet characters. And so you can't do that. If you want to do that, you have to disambiguate it by putting brackets around the variable. And in the Google, if you go read the Google style guidelines for writing shellcode, they require it. So everybody at Google writing shellcode is required to always wrap their variables in these brackets. I think that's a little bit of overkill. It makes it kind of annoying to do that. But the reason they've argued to do that is to avoid these kinds of problems, right? And the shell programming language does pretty well at figuring out for the 0 to 1. But the reason I had to tell you about this now is because I just found out that when using, when we use 1, let's use 1. So apparently the shell knows about the special variable parameter $1. But if we try to use 10, it doesn't know about it. Look at that. Let's actually try it. Rob 0 user. What? That seems kind of weird, right? So anything over 1, from 1 to 9 are special and the shell's okay with that, but the other ones have to be disambiguated. And the answer to my question, can I use, oh, look at that. Well, that's not number 10. Let's do it. Let's do 0, 1, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so you can, so the answer to my first question, can you have more than 10 parameters? Yes. I never have. I probably never will. But now you know that you can have them, but you always need to disambiguate them. This, by the way, is completely valid if you want to do that as a kind of a default. You can also do that, right? And that will work. Okay, so we have 6 or 7 minutes left, so let's just go ahead and recap. We have spent the day today doing primarily basic, a basic piece of code and talking about how to get data from the environment variables, from local variables within the program, and from variables that are arguments or positional parameters into the code. So that is the thing you should take away from today. That's what you should master. And for fun, you should go look, if you want to, you can go look at some other languages and see how they deal with the same thing. Every language on the planet can deal in some way with most of them. Some of the functional languages are a little creative, but they all have this idea of being able to pass in stuff and kind of this idea of an argument and a parameter and all of that. Okay, you also know how to run the code to do your evaluation, and you know how to disambiguate names of a variable from the actual string that it might be a part of. We learned about the fancy stuff that you can do with printf by providing more than one argument. And next week, when we come back to this, we're now going to start encapsulating our little bits of code into bigger bits of code. And if you know, we're going to look at procedures and functions and what those are. And basically, that means we're going to be writing programs inside of programs and we're going to bring those programs together in a way that gets very powerful really quickly. So that's going to be the focus for next week. And this has been everything for this week. So go ahead, have fun with that. Practice with the parameters. Look at your different environment variables. I'm going to go ahead and spend just a little time reading the chat, see if I missed anything really major. It is the same for functions. A lot of people are already saying that you can pass arguments to functions, which is why we'll talk about functions next week. So stay tuned for that. And it looks like that's all the major stuff that I can see that we've covered. I don't see anything other than, just regular questions. So we're going to go ahead and end there. And that is all for the Beginner Boost this week, week 17. Look for the video very shortly. And if you have any questions, of course, hit the Discord. You can come into the YouTube. This is the first week that we have streamed to Facebook, YouTube, Twitch, Twitter, and Kick all at the same time. So if you're seeing this video in any of those other places, or you're going to the regular YouTube place, just know if any of those places that I just mentioned are available to you and it's easier for you, those are available for you. So I'll just mention that. As always, I appreciate your subscriptions, your likes, your donations, your whatever you want to do. And that's all for today. Bye.